So Scopely is a mobile games developer, publisher. We're based in Los Angeles. Also have another office in Barcelona and 8 studios around the world. That sort of gets into some of the motivation for wanting a tool like Spinnaker. We're in the mobile business, free-to-play games, large audiences, and we're also in the creative business, which means that we have a desire to, and we look at technology solutions, making sure that game studios are studios where there's going to be creativity and autonomy. As a publisher, though, we also have an interest in there being, it all has to add up to a business, and all has to add up to something that we can have some confidence in, some reliability, without unduly constraining the creativity. So the Scopely itself is 7 years old or so, almost 8, and I've been there most of that time. And we are, as it gets into what we deploy and where we deploy, we'll get some of those details. We are an all AWS shop, and so despite the best efforts of the Google sales team, and that's us. There are a few. Those are some marketing shots of a couple of the currently live titles, including, I guess, that Looney Tunes one in the bottom. I guess that's bottom left for you guys. Is coming out next week, our next big launch. But it's been announced already, so no reveals here. This is, despite being about games, this is Spinnaker for games is still mainly about Spinnaker and cloud services. It's not mainly about 3D graphics and pretty pictures, so I think those may be the last pretty pictures beyond Spinnaker's own beautiful art. We have been using Spinnaker for a couple of years now. We've been in prod. I believe our first workloads starting to deploy with Spinnaker for some internal teams in early 2017. All of the studios except for 2 are deploying their workloads with Spinnaker and deploy targets, Kubernetes, AWS, EC2. And we are an Armory customer. They don't pay me extra to say that, but it's important when we get into the details of the choices around management and that. That's where the way we're using it, particularly early on in 2017. I believe that's before Spinnaker had versions, and so every service had a version. Which, as I think back about it, I have no idea how that was ever a good idea, but that was only one of the many things that made us very concerned, very excited about the potential of the software, very concerned about the state of it, and so we have been using it, and as over the course of the past year and a half. The backend deploys for every single game we're making and all of our new projects have moved over to it on its merits. And we'll talk some more about what Spinnaker adoption means to teams, but we don't have much of a central infrastructure team at Scopely, and therefore a technology like this only grows through its merits, and it grows through being of value to the individual game production teams. I want to talk a little bit about the game development process, because the way I look at why teams find value in investing in efficiency and reliability in deployment, part of it comes from some of the challenges that I think are somewhat inherent to games. You can probably find parallels in other systems, but for me, I see them as problems with games because that's where I work. The long cycle of development in making a game is sort of driven by the long cycle of releasing the next major version of the mobile client. And so, the tentpole releases of a mobile game tend to be monthly or month and a half. There may be intermediate releases between them, but as anyone here who's worked in mobile knows, there's also a limit to how frequently you could possibly release without frustrating users or just ending up with one thing in the review queue with Apple while the other ones are still in the queue. So there's just a fundamental limit on how continuously your CD can be on mobile, and even if it is, it's just it's a tax on your users to be pushing a download every day, and so for us, the major release cycle is about a month to a month and a half, and then there may be patches, follow-ups between those, and there are a lot of things that come together fundamentally. I mean, I see as mainly 4 major tracks of people's work and ideas that have to go from idea to being in the hands of users. There's the game client, and so we are a Unity shop, and so that means there has to be some version of the client code, all in C#. That is ultimately the version that's built, and you build out your final deploy artifact and get that through Apple review and submit it to Google and get out to your users. That's one thing. That sort of has the slowest inherent timeline, as I said already. But it's also, there's a backend component that, many of these things have a backend component that also has to be live, has to be running on the right servers in the right regions. And another big area is that games, at least the way we write them, and I think most modern game development, particularly on mobile and free to play, is a huge amount of game design and configuration that changes on some schedule. And so in a character-based game, it may be character strengths, it may be the costs of items, it may be exchange rates, it may be sales. What configuration means is very broad, but it's also a thing that must be designed, tested, reviewed, rolled out to users. And there's art. There's art broadly stated. I mean, there's a lot of assets that must be generated. They must be generated, pushed out to the right CDNs in the right compression formats, and then your clients must be told to go pick them up. And so making a major feature release involves all of these things. Not everything requires everything, but fundamentally, the big cycle of the entire game team getting something done, it involves all these things happening. Historically, I mean, at least the default pattern we tend to see with studios is that they tend to sort of think of it as one big thing. That we're going to get there's going to be this next release, release 6, and here's the stuff that's going to go in it. We're all going to work on it, and then when it's code complete and all the art is done and all the designs done, we're going to start testing it. We'll fix the bugs in it. We'll have an RC. We'll check that. We'll get it out to our users. At which point, your users are hit with a change, potentially new client binary, new assets, new balancing changes, and a new game backend all at once. And that's a long time, and so studios tend to say, well, that's an 8-week process, and so, but we don't want to be every 8 weeks, so we'll just sort of have a few different parallel tracks that work that way, and we'll stagger them. And this scales up in the game business from, sort of the annual cycle of FIFA on console, which is a 2-year development cycle that is staggered by a year, basically, and they just sort of overlap by a year and do this. For us, if they're staggered with a release coming out every month, and maybe there's a 2 or 3 month development cycle for every major cycle. This is a problem, though, because this does let you get more changes out to your users, but there's just so much change that can be happening at once. What we find, basically, is that this desire to sort of get all of your pieces in the right state and get your golden master version that you're going to be able to ship, it gets people in a position of relying on, well, this comes out, we're going to force update all of the users to the next version. There will only be one version live at a time. There will be, it's all going to go out at the same time, and you are in a large iteration loop. And that basically, when I'm trying to get a team to move away from that, I refer to it as a big bang release. Like everything has been totally validated. You have your gold master version. You put it out there. Inevitably, this goes poorly. There's such a large change surface when you have changed everything live at once that your ability to regress all possible impacts to a large complex game is just too much. And I think the most sort of interesting detail around sort of the having big bang client server changes at the same time, everyone updates at the same time assumption within development teams is that particularly client and server are changing at the same time. It doesn't protect developers from themselves in terms of making the smallest change that they can make in the direction they're aiming for, because if you're going to change everything in a sort of a coupled fashion between client and server, you can totally rewrite your API contract from version to version. There's no need to find a natural evolution that you will roll out. You can just sort of redo it again and again. And so it doesn't sort of help people find the minimal diff. And because so much potentially could change in each cycle, it really, the thing that ends up mattering for us most as a company is that you really struggle with timeline reliability, because so many, your the changes you want to get out for art or for your new game design, they require a change in the contract for how character power is represented in your game modeling system, and that's held up because that is in the same big change that you're trying to get out with a whole bunch of other changes, and you can't get anything out. You end up having to hold up the whole train for anything going wrong. Those RCs have to be restarted because something goes wrong. Changing a lot of time, as we all know, news delivery has downside. I guess I don't need to tell people here about the risks of large changes. But the thing is, games have things that make it hard to ship a small diff. Like, as I said, even just the basics of the timeline on mobile means that the things people talk about, like deploying 500 times a day, you cannot deploy to a mobile app store 500 times a day. It's not possible. But there are other things that are inherent to it. You have PvP gameplay. You have people against each other. If I roll out changes and say, this person has changes and this person doesn't, I have to make sure that we've preserved the integrity of the experience for our users. We can't have, when things change, they must change in a way that's fair, and that doesn't break, or both fair and stable. Sometimes you could have issues with being fair. You could also have issues with person on a new version plays against person on an old version. Does this work right? You've got to take that into account. There's other things like I guess everyone has marketing considerations. And another thing will just be, I think everyone in the gaming space is aware of this. It's the automated testing, I think, runs into greater challenges in game making than it probably does in some other areas. The exploratory testing, directed testing, scripted testing by people ends up playing a very large role, particularly for client changes in our world, which also means you have to find some way to limit your demand for human testing as you find a way to get more diffs getting out to users. And so what we've tended to do with studios is try to get them some degree of decoupling of these three types of problem. So their approach to releasing each of the three major areas is not so bound up together. And so what that means for us is that your client has its big cycle, but at least maybe you can get to a weekly cycle with your backend code. We have had to find a way to centralize it without having a full-time release engineering team, and there are edges of it that I try to whisper in the ears of Spinnaker core developers when we're here at the summit about when you have 8 studios and there are new AWS accounts and Kubernetes clusters coming online all the time, where the tax on even a central non-full-time team for this are still substantial. If this account needs to be created, this cloud AWS account needs to be added to Spinnaker, these Kubernetes namespaces need to be added, these users need to have access, this new Google group needs to be able to access these things. There's a churn here that we have to deal with. And then upgrades. I will tell you, frankly, the one the Spinnaker that we use for the game studios, unfortunately, it's running a version from January because it's had a couple of upgrades we've had to roll back, and we'll do the next one soon, hopefully. But it is a system that has so much of a wide surface area that it is not hard to run into edges where maybe you are one of the few people using it if you use it a lot. It is easier than it was before, though. So we have a centralized Spinnaker. I'm not going to go into, I want to get into some of the user story stuff here. But we have a centralized Spinnaker, but we don't take a very strong opinionated stance at the moment in terms of how people should use it. What we do centralize is that it is an option for teams. We share sort of best practices, what other teams have done, share examples of pipelines. The most recent team to adopt Spinnaker from what they had done previously did it actually with no conversations whatsoever with me, with Steven, some other people centrally. We added their account to CloudDriver, added them to the appropriate Google group, and a month later I realized they were deploying product with Spinnaker. I had no idea. So I think I saw something of a success in that it is the case that if you just read the docs and you're not afraid to try things, the team, without any further consultation with people who have been using it for other studios, could just do it. But we, we are, I think, always looking at how we can help teams learn from each other, because our opinion around what makes a good deploy strategy is shifting and always changes. But so we do centralize with somewhat reluctantly. It's the only way we really see it as being possible, but we also we didn't really want the responsibility of centralization either. We do lean on a vendor here as well to help with this. Let's get into some stories though. And so I want to go, basically the remainder of the talk here is really looking at some of the ways, so the strategies, the ways that we approach that game deploys tend to happen, and some of the things you run into. And so let's dig in. Now we get pretty pictures again. So a common sort of dev deploy, we usually in our game teams, our development environments do continuously deploy, and so usually it looks something like this. And we'll go a little bit into, actually, can I? It's going to be a pain. And so basically that does mean, there's standard bake happening, and then bake deployed to the one cluster. We tend to be have a monolithic backend. There's enough different things to deploy with client, assets, game configuration, and game server that we don't want there to be 45 game servers with different components of game. We keep it at mainly one. Some studios are a little bit different. It tends to be one. Maybe there's an API worker layer, scheduled job layer, but it's mainly one artifact. And deploy, and then we run a test suite, an additional test suite against the deployed API server, and then we're done. It's a continuous deploy on develop. It's pretty boring. The one consideration here around develop is that this actually is usually one of the most contentious things for Spinnaker adoption in a game team, is that the baked AMI deployed DC2 is really, it's even when you try hard to speed it up, it's still quite slow. And so for a game team who really is used to a quick turnaround, it's a very frustrating delay to have to eat as a team, is that the time from code in repo to code running on server has grown to at least several minutes. One thing we do to help with that is we tend to deploy first, test later in some of these environments. Run some tests later, so some first, some later, because it's a team may be biased in favor of just getting it out there, because there is a contract with the client team, and you may want to be able to get that up there so that client team is quickly unblocked. Now in prod, most of what we'll look at is prod. Here's I think probably the same game. I'm not sure. I don't remember how they work. Frequently, any game in production should be using a canary deploy. We don't use Kayenta at the moment. We've looked at it. We looked at Armor's Barometer before that. For us, a canary usually is judged manually. And so it's really standing up a single server into the ASG. And so if we have 100 up, we add another one. And we're not looking for an automated analysis. We will just do an analysis of the one instance, looking for anomalies and logs, looking for any errors it's throwing, looking at load potentially, looking at response times on that instance. It just takes an even share from the general load balancer. We usually would also add it to its own load balancer if you look at the details of the deploy, so that you can hit it specifically if you wanted to. And then it's a manual check. Just, hey, do we want to proceed or not? That is very helpful, particularly for things like running into cache inconsistency problems for running in a mixed fleet mode during a deploy, or frankly anything. And so we could grade it, but we don't at the moment, because most of the things we found don't have a good, they're exploratory really. You look at it and explore. We're also deploying few enough things to production per team that the scale's fine. If you're deploying weekly, if the process is that you spin up a canary, you also deploy to staging, so you get a manual test against the staging environment, and then in the morning, you check the canary, check all of its logs, everything's clean, proceed to full rollout. It's a straightforward process. You're on a weekly schedule in the first place, and you're fine. This just sort of is one of the big things I love about Spinnaker, though, is that there's an option usually for it's like a deeper adoption, like a technology here that you could go full automatic. But also manual judgments are a great feature. Like frankly, sometimes you just need to stack your, let your process embed the underlying business structure of it. And so like there is there's a manual QA team and that will do part of this, and there isn't a manual QA stage. It's just a, hold off, follow up later component. This is we're going to see a few pieces from another deploy strategy that goes into some of the other ways that we use Spinnaker. And if we look at this one, we're going to see it starts with check prod tables. I don't even remember what the stage does. It's a Jenkins job. It's not I didn't write that. When I last worked on this pipeline, I didn't have that stage. That's another good thing. Hopefully, presumably it's a useful and very valuable stage. Oops. But I don't know what it does. Now, as we get into this is a team that uses their production rollout uses a stage they call Live Mirror, which is where it is basically where anything goes before it goes to full production. It's the same scale use the same instance type. It has the same game configuration as what's in production. And we actually build the AMI, push it to Live Mirror, and then promote it to production using a proper AMI promotion. This is actually one of the things that it's doing it's promoted the AMI cross account as well, and so there's actually one account for dev, one for prod, and so in this process the same AMI is being reused from one to the other. But we look into the arrows here. The first step we'll look at a little bit later is this bootstrapping Live Mirror, and we'll see what that is, and then it does execute Liquibase, and so it's database migrations, and then it does deploy to the 4 clusters. And so there is actually a separate AMI for each of the 4 components of this application. It's off a single code base, but it deploys 4 different pieces: worker, API, admin tool, and what's the other one? Cheat, I think they call it. It's the APIs that you can't hit if you're in production because they're for cheating. And they're a separate cluster. They're not in production. Don't look for them. And they have those, and then at the end, they also have a canary in the same strategy, a canary of pass it or fail it, also standing up a single instance just of API for a manual judgment to be followed on it. And we'll go a little bit into bootstrapping. And so in here, and you could see it's in other pipelines as well for all of our titles, there's something called bootstrapping. And I guess bootstrapping, we frequently refer to as infrastructure deployment, but it's not always that. And it's one of the things that is on the periphery of your code. There inevitably relies on something, whether it's tables, whether it's databases, whether it's queues, whether it's something that's not your application itself. And at Scopely, we've basically seen 2 patterns for this. In some cases, what we're seeing is that the game server knows what all the infrastructure it needs sort of programmatically, and so maybe there's classes that are annotated with a Dynamo table that their content is stored in, or something like that. And then there's a bootstrapper entry point that you can just run, and that will check the environment it's in, check if it has all the stuff it needs, create things it needs, make the changes it needs, and you just need to run that. And so a bunch of our games work that way, where you can sort of, there's a bootstrapper executable that's also part of the game server code base that inspects the whole code base, it identifies what it needs, identifies differences from the current configuration, and makes the appropriate changes. And for those games, we just run that. We invoke that as a Jenkins stage, and that theoretically should be done differently, but we don't have a good place to run an arbitrary .NET executable. These games are on .NET Core on Linux, and so they tend to just run it from Jenkins. And what we're going to look a little bit more at, but we also see is using sort of standard tooling, and the configuration is just sort of versioned next to the code. And so this is usually a CloudFormation template or templates that describe everything this thing needs to run. And in particular, the one we just looked at here, the bootstrap step there is just running the CloudFormation, applying the CloudFormation changes, also running as Jenkins stages. The downside here is that you kind of have to double write what your application needs. If you take an approach of using fancy annotations inside your code base to describe everything you need, then potentially you don't need to write it somewhere else. Flip side, you have to write all of the how do I make changes in infrastructure code yourself, because that itself will not be executable via Terraform or CloudFormation. So with CloudFormation, we take I think what I hope is a fairly standard approach. It's not built into Spinnaker or anything, at least at the moment. But the way this runs is we run basically a 3-step process. One is create change set, so a script on Jenkins to take basically the artifact that feeds into this, which is the zip of all of the CloudFormation templates and their variables to be applied. We throw that up against CloudFormation to see what to create a change set, and then if there's no changes to be made, we're just done. We end the pipeline. And if there are changes, then it's a fairly straightforward process. We don't apply them directly. We prompt. I think we have a support for forcing it through for places where are not production, where you may not care about this. But just apply those changes, and it uses that sort of 2-step plan apply thing you have in CloudFormation, so we use this sub pipeline almost as if it were its own stage, because this is a fully parameterized pipeline that we just stick into stages throughout Spinnaker wherever we want it, and it takes a fully parameterized set of CloudFormation changes. This works pretty well for us. The only caveats we have about it are just caveats about CloudFormation and how some of CloudFormation can be confusing. It can get stuck. It can get stuck trying to roll back. Nothing support can't fix. But in general, though, it's for us it allowed teams to sort of quickly iterate on this and get the appearance of first-class support without Spinnaker having any support for CloudFormation. Not that AWS shouldn't add it, but it doesn't actually have to be there. Similarly, we see continuing into other stories. Our load testing, we have seen some preliminary cases of trying to directly integrate it into pipelines. It usually looks something like this, though, which is more of its dedicated pipeline. We do have load testing usually as part of a standard part of our release process. That doesn't mean that we bake it into the pipeline. I think there's been some mention of people, process, technology. We do want to formalize. There's a straightforward way of running a load test with spinning up the right number of locust workers and hit the right endpoint with the right scripts. That doesn't mean that has to be formalized and as an explicit stage inside every production pipeline. That might be an eventual step or not. Right now, what we see more commonly is that there's a well-defined pre-built pipeline that makes it super easy to run a load test, but you decide when you're going to do it because you probably want to be explicitly monitoring it, having some opinion around what you care about in this particular load test. And so this one is just I think under the hood it's just a very simple Kubernetes v1 job, or I don't know, it's a very straightforward load test. Backed by Kubernetes, but nothing special there. And you're able to teams just are still lets teams. In this case, actually, what we got was the team that this is using this Kubernetes backed load test. They had never used Kubernetes before, and this for them it looks the same as anything else in Spinnaker, and so it's one of these cases where sort of blurring the line between two different cloud providers made them able to benefit from it being much easier to scale Locust on Kubernetes. Without them having to develop any real expertise with Kubernetes. So I mentioned that one of the areas where Spinnaker is helping sort of us to get those horizontal slices of things to deploy in games is configuration. And as we looked at sort of how teams struggle to get efficient development pipelines human-driven development pipelines for making changes to how a game is configured. One of them was making sure that you only have one variable at a time, by which I mean that if I'm going to be changing the way that a character evolves, if sort of it can be upgraded or something, its power curve, I don't want to have to be guessing about what version of the game backend it is. And usually what we found is that most environments fell into, so as we were looking at studios that had maybe 100 different environments, and anyone could push code to environment with just a name they come up with. And we run into issues where people didn't actually know what code they were working with. And so then they really wanted to be iterating on game configuration. They didn't want the code to be changing out under them or have to ask someone to push the latest up. And so now for this particular studio, they've just wired it up so that every time they push to production, just downstream of production is all of the environments that are supposed to run the same thing as production. And so game design 1, game design 2, live ops 1, live ops 2, QA 1, QA 2, basically all intended for iteration on game configuration. The environment's totally isolated from production, and that, once again, it's an AMI promotion. It's the exact same AMI that's in production. After it goes to production, the same CloudFormation changes are applied, the same database changes are applied, and then people can iterate in those areas with full confidence they're running what's in prod. Or within a few minutes of being in prod, it'll be out for them as well. There's a similar family of things that are tracking what's in the develop branch. This really was a big part of allowing us to get away from exploding numbers of ad hoc environments, because it turns out if you sort of looked at what people were trying to do, usually they were only really trying to iterate on configuration or code, but not both at the same time, very rarely. Similarly, game developers and backend developers, sometimes have built up systems to make it very easy to spin up these ad hoc environments with any branch and a whole full stack behind it. Not only is that very expensive from an infrastructure perspective, what we've done for this studio in particular, and it's a pattern we're trying to stick with, is trying to make it so there's a fixed number of environments. There's dev 1, 2, 3, 4, and you can push any branch to any of those environments, and it'll just be there. And so you know that Alice's branch is running in dev 2, and it's all considered ephemeral. Someone else can deploy something else there. And yes, that means that Alice can't have her branch in dev 2 for a month, but we don't want people to have a branch running for a month. And so one of the things we found is that, in particular, just the constraining it to be, this being strictly a temporary way of standing something up has encouraged people to be making smaller change sets and really pushing people down the path we really want them to be on, of smaller, more compatible sets of changes that don't require such tight orchestration. And so this was a good thing in our perspective. And sort of just a lot of our first usage of Spinnaker was actually outside of game deploys, and I wanted to sort of call out a little bit of other areas. And one of the things that we've moved just in the past year to be deployed with Spinnaker was Airflow, which is a job orchestration framework for data systems and orchestrators deploying orchestrators. We actually do continuous deploys of Airflow. And so this was an interesting one for us because it is a tool that is only somewhat stateless. And so it's stateless in that you can replace any of the components of Airflow, and it will pick up, if you replace an Airflow worker, the work that was in progress will be picked up by the worker that replaces it. Unfortunately, if the Airflow worker was in the middle of executing a 3-hour Spark job on a 400-node cluster, that job just got thrown away. You've got to start over and hope the whole thing was idempotent, which it probably was. But still, that's an awful lot of work to throw away, and it means that that really constrains your ability to deploy Airflow a lot. We deploy Airflow probably about 15 times a day. And since that doesn't give you much time for a job to run, we had to do some work. So one of the things we did here was just, we were able to, without changing anything about Spinnaker except, I think, a configuration of Orca timeouts for waiting for things to terminate, is we stopped the scheduler right away. I don't even know what config migration does. We do something, I think it's like a database upgrade. We deploy the new code to the edge of a Cloudera cluster. We deploy the new workers, and if you look at the detail of this particular worker, what it will do is will allow the old ones to stay up as long as they keep ping. It's using the Amazon ASG termination control, so they actually will keep themselves running. They'll get the kill from instance will want to start stopping, but Oracle will just keep waiting for it to stop, but it will already spin up a new worker. And so we'll stop picking up new work from Airflow, but it will be allowed to finish its current work. And that's actually allowed us to, potentially we may have multiple workers from older versions of Airflow still finishing their work, and the new ones have been deployed. And so this is able to keep moving, and it works fine. And so it was pretty important for us, particularly because now we have, I think, 4 different teams that are developing ETL that feeds into Airflow. And so they would need to get their work out quickly. For us, at this point, Spinnaker, it's a big part of how it's the thing we reach for any of these as the technical component of helping studios do that decoupling of work to get a more reliable delivery. And so it's also, at this point, standard for any new projects at Skillthing. We're pretty happy with it. It is certainly not a project that's done, but the velocity is there on Spinnaker itself. So we're looking forward to helping push it forward. That's Spinnaker at Scopely. So happy to answer any questions you might have.